and we're going to be specifically looking at uniform acceleration. How to see something, a system that has uniform acceleration, we will basically just give an object a constant velocity. If there's a constant velocity, then we'll have that uniform acceleration. Atwood's machine is pretty simple. It's just a 1-to-1 pulley ratio. And we'll be dealing with one mass and another mass, just changing the distance. But to understand it a little bit more about forces and how they work with masses, we'll look at different types of forces, specifically weight, friction, and tension, and gravity. We need to make sure that the system is first at a neutral state, so the forces will all add up to 0. So the net force will equal 0. We'll have these two systems here, M1, M2, and G. Then once we have the equal masses, we'll then need to compensate for the frictional force. When we want to compensate for the frictional force, we'll just be adding more weight to the actual side that we're trying to displace, and we can account that for right here. Instead of just having it as F for friction, we'll have it as M sub F for the mass to overcome the frictional force. So we'll have a net force which can equal mass 1 minus mass 2 times the gravity, and then we'll break it down to this form. It makes it easy for us to solve for the acceleration. With a little bit of algebra, we can solve for acceleration here. So once we have our acceleration here, we can then compare it to what's given in the book. So we'll have to compare our results and see how they differ. That is really the experiment. It's just seeing how much weight we need to overcome to add for the frictional mass, to see if we can have a constant velocity so that we can see our uniform acceleration. And then once we have our uniform acceleration, we can use it to calculate gravity. All right, now we're going to do the procedure portion for the Atwood machine. First things first, we just need to make sure that everything is balanced. So we'll have 560 on one, including the hanger, and 560 on the other, 560 grams. And so now they're balanced. To get the distance that we need, we'll just use our measuring stick, measure it from the top of the crash pad and then to the top of M1, which comes out to 162 centimeters. Then we need to find what the amount of weight we need to add to M2 to overcome the friction. So I've put 1 gram on, and I'm going to give it a gentle push. And let's see if it will work better with 2 grams, because we want a constant speed. Gentle push. So that now we have found that our M sub F is 2 grams. We'll be able to get the full mass of the system, the total mass of the system. And so with M1 fully raised, we're going to get 2 grams from our M2, transfer it to the top of M1, and we will record how much time it takes for M1 to reach the bottom of the pad. And we're going to do that a total of 5 times. We'll transfer 2 grams over to M1 and record the time that it takes for M1 to travel from the top to the bottom. You'll have to give it an initial push, and if it stops, you'll have to restart and give it a better initial push till it reaches and hits the bottom. But you'll do that 5 times, take the average time that it takes, And then using equation 10 and equation 16, you can calculate acceleration. You'll compare equation 10 and equation 16, their differences, by using the percent difference equation.